Hello guys, today we're going to talk about MOSFETs, what they are, their uses, how they work, and some of the advances we're seeing today with today's MOSFETs. So the MOSFETs are part of the family of the transistors. As a matter of fact, MOSFET is short for metal oxide semiconductor field effect transistor. It's a field effect transistor, or FET, with an insulated gate where the voltage determines the conductivity of the device. It is used for switching or amplifying signals. The ability to change conductivity with the amount of voltage applied can be used for amplifying or switching electronic signals. MOSFETs are now even more common than BJTs, bipolar junction transistors, and digital and analog circuits. The silicon dioxide forms the gate of the MOSFET. It is used to provide isolation by preventing the direct flow of charges on the gate to the conducting channel. A MOSFET is by far the most common transistor in digital circuits, as hundreds of thousands or millions of them may be included in a memory chip or microprocessor. Since they can be made with either P-type or N-type semiconductors, complementary pairs of MOS transistors can be used to make switching circuits with very low power consumption in the form of CMOS logic. So why MOSFETs over BJTs? MOSFETs are particularly useful in amplifiers due to their input impedance being nearly infinite, which allows the amplifier to capture almost all of the incoming signal. The main advantage is that it requires almost no input current to control the load current, and that's why we choose MOSFETs over BJTs. So the MOSFET is composed by source, drain, and gate, and body terminal. The B or body is frequently connected to the source terminal, reducing the terminals to 3. It works by varying the width of a channel along with the charge carrier flow, electrons or holes. The charge carriers enters the channel at the source and exits via the drain. The width of the channel is controlled by voltage on an electrode called gate, which is located between the source and the drain. It is insulated from the channel near an extremely thin layer of metal oxide. A metal insulator semiconductor field effect transistor, or MOSFET. There are several types of MOSFETs. MOSFETs work in 2 modes. First, depletion mode. transistor requires a gate source voltage to switch the device off. The depletion mode MOSFET is equivalent to a normally closed switch. Second mode, enhancement mode. The transistor requires a gate source voltage to switch the device on. The enhancement mode MOSFET is equivalent to a normally open switch. The P-channel MOSFET. In the P-channel MOSFET, drain and source are heavily doped P positive region. On the substrate is in the N-type. The current flows due to the flow of positive charge holes, and that's why it's known as a P-channel MOSFET. When we apply negative gate voltage, the electrons present beneath the oxide layer experience repulsive force and are pushed downward into the substrate. The depletion region is populated by the bound positive charges, which are associated with the donor atoms. The negative gate voltage also attracts holes from the P positive source and drain region into the channel region. Now, N-channel MOSFETs. In the N-channel MOSFETs, the drain and source are heavily doped. N positive region, and the substrate is P-type. The current flows due to the flow of negative charged electrons, and that is why it's known as the N-channel MOSFET. When we apply the positive gate voltage, the holes present beneath the oxide layer experience repulsive force, and the holes are pushed downward into the bound negative charges, which are associated with the acceptor atoms. The positive charge gate voltage also attracts electrons from the N-positive source and drain region into the channel. Thus, an electron-rich channel is formed. The working principle of a MOSFET depends upon a MOS capacitor. The MOS capacitor is the main part of the MOSFET. Semiconductor surface at the oxide layer. It's located between the source and the drain terminals. It can be inverted from P-type to N-type by applying positive or negative gate voltages. When we apply positive gate voltages, the holes present under the oxide layer experience a repulsive force, and holes are pushed downward with the substrate. The depletion region is populated by the bound negative charges that are associated with the acceptor atoms. The electrons reach and the channel is formed. The positive voltage also attracts electrons from the N-positive source and drain regions into the channel. Now, if a voltage is applied between the drain and the source, the current flows freely between the source and the drain, and the gate voltage controls the electrons in the channel. If we apply negative voltage, the whole channel will be formed under the oxide layer. Some of the applications for MOSFETs today are amplifiers, regulation for DC motors, switching and amplifying signals, and more. Types of MOSFETs. For example, Nexperia just introduced the first ever silicon carbide or SIC MOSFET. This cutting-edge 1200 volt discrete MOSFET delivers top-tier performance, propelling the worldwide industry towards sustainable energy solutions. So this is probably gonna be used in charging stations. The company has unveiled two discrete devices with a voltage reading of 1200 volts encapsulated in a 3-pin TO-247 packaging, featuring RDS on value of 40 milliohms and 80 milliohms. This product's NSF 040120 L380 and NSF 080120 L388 as in Apple 0 represents the initial offering in a series of planned releases as the company prepares to expand its SIC MOSFET portfolio, catering to a diverse requirement in both through-hole and surface-mounted packages. The release of these SIC MOSFETs is a pivotal response to a surging market demand for high-performance SIC MOSFETs, primarily in industrial applications, including electrical vehicle charging infrastructure, uninterrupted power supplies, and inverters for solar energy and energy storage systems. One of the standout features of the RDS on a critical parameter affecting conduction power losses. Unlike many current available SIC devices in the market, the company's innovative process technology ensures industry-leading temperature stability with RDS on values increasing by only 38% over an operating temperature range from 25 Celsius to 175 degrees Celsius. Some of the specifications for these SIC MOSFET are drain source voltage of 1200 volts, continuous drain current of 81 to 113 amps, body diode drain current of 97 amps, pulse drain current of 250 amps, power dissipation of 395 watts, in an operating range and storage temperature of -55 to 175 degrees Celsius. Another company that's making long strides with high-power MOSFETs is Infineon, with the Optimus 5. The continuous progression of transportation and electrification is underway. Alongside traditional passenger cars, electric power is increasingly being adopted by 2- and 3-wheelers as well. As light vehicles, as a result, the market demand for electronic control units, or ECUs, operating within the 24 to 72-volt range, is anticipated to keep expanding in the forthcoming years. Infineon Technologies AG has launched automotive MOSFETs designed for 60 and 120 volt applications to accommodate this trend. And I'm going to leave you the link so you guys can take a look at this article I just mentioned. Carbon nanotube MOSFETs with control polarity. A team at the University of California, San Diego, in collaboration with the Taiwan Semiconductor Manufacturing Company, has recently created a new carbon nanotube metal oxide semiconductor field effect transistor using localized solid-state extension doping. One-dimensional semiconductors like carbon nanotubes offer the potential to reduce the gate length of the metal oxide semiconductor field effect transistor, or MOSFET, beyond what is achievable with silicon-based transistors. However, creating industry-compatible doping methods and controlling the polarity of these devices is a complex challenge. These top-gate complementary carbon nanotube MOSFETs have been developed using localized, conformal, solid-state extension doping to determine the device polarity and ensure balanced performance. In these transistors, the channel remains undoped. As always, thank you guys for watching. And if you like this video, please like, share, and subscribe.